I want to show you how you can save lives with JavaScript. I have been working in the past 15 months developing JavaScript offline applications to help on the Ebola outbreak response. And it has been quite a journey and impressive thing, but not always an easy path. We have found a lot of challenges, we have made a lot of mistakes, and we have learned a lot, thankfully. So I want to share the learnings with you. So if you happen to find yourself developing offline applications, then maybe you won't do the same mistakes. All right. Ebola. I'm sure you all know a lot about Ebola because it has been in the media quite often in the past year. But I'm going to review some facts so you will understand better how the fight against Ebola works. So Ebola, unfortunately, is quite an unknown disease. One of the things we don't know about it is how to cure it. There is no confirmed treatment yet. So the only thing you can do is to take the sick people to a medical facility and keep them strong and hydrated, and make sure that their body is at their best to fight the virus. However, there is a couple of good things about Ebola in comparison with other sickness. One is that contagion requires direct contact with body fluids of an infected person. It's not airborne, like a cold, for example. The other one is like, while it is very infectious, the sick person is only contagious after showing symptoms. Unlike the flu, for example, that you are probably giving to everybody around you and you don't even realize you are sick yet. We also know that the incubation period is up to 3 weeks. So the way the response to the Ebola outbreak works is by trying to stop it from spreading, and this is done by contact tracing. Contact tracing means that when you find somebody who is sick, after bringing that person to a hospital to be treated, you have to find everybody who has had a significant contact with that person for the past days. And these people are potentially infected with Ebola too. So you have to keep them in a sort of quarantine and check on them for 3 weeks to see if they develop symptoms. If they don't, then awesome, they are healthy, and if they do, then you continue the process. So there are 2 important things on here. One is following up in contacts, and the other one is making sure if somebody is sick and that was not a contact you knew, then you find that person as soon as possible so that you can stop the sickness from spreading further. That was quite difficult in the West African countries where Ebola hit very hard, in Guinea, Liberia, and Sierra Leone. So what they did is to set up an emergency phone number where people can call with any Ebola-related emergency, saying that somebody is sick or somebody is dead, or just asking for information. Education is very important here too, because at the beginning of the outbreak, people didn't know how to deal with Ebola, or what was it, or some people didn't even believe it existed. So how does JavaScript enter the equation here? I work for eHealth Africa. This is a Nigerian-based NGO that aims to help vulnerable communities live healthier lives, especially in West Africa. And I'm part of the software team, and we try to apply technology wherever it can to help improving these health systems. Part of it was working on the Ebola outbreak response. What do we do? First, we started in Nigeria, because this is where we are based. And we realized that the way the response is working there is these people, the contact tracers, that go to visit the contacts at home every day and see if they have developed symptoms. And they were using paper forms. And this is far from ideal, because paper is like, paper doesn't have error checking. If you forget to fill a mandatory field, paper is not complaining. Or if your handwriting is absolutely horrible and nobody understands. If you write the name wrong, and then it's not clear which contact did you follow up. Also, it's easy to lose. I manage to do it all the time. It can be destroyed by getting wet, for example. And paper travels slow. You have to take the paper yourself to the place you want it to be. The place you want it to be is, in this case, the Emergency Operations Center, where they take the information and decide what to do with it. And they also digitalize it, so they can do further analytics and plan the strategy. But again, digitalizing it is like typing all this paper, which is slow and error-prone and something we humans are very bad at. So what we did is we realized this is basically a form, right? So we provide them with a very simple mobile application where they just have a drop-down where they select the person they are following, and this way they cannot make mistakes with the name. And then they fill the symptoms and save. And when they do, as a bonus, you can store the GPS coordinates. And this way, you are sure that the person really visited the contact. This way, the data were digitalized from the very first moment. So we were able also to provide the Emergency Operations Center with another tool that let them see the information about contact tracing and about the outbreak in real time. Internet, God's willing. So in the call center, it was even a more extreme case because first, the call center was in Sierra Leone, where the scale of the outbreak was much bigger. And also, there were a lot of calls arriving every day. So there is the operators who are receiving the calls, and then there is this, you can see two teams here, like the burial team, the quarantine team. And there is also the ambulance team for sick people. So they were using different things from paper to Excel, but it was in general slow and they were not so happy with it. Imagine paper, for example. You have the operators taking calls for very stressed people and they have to type everything super fast because they have to collect a lot of data. And then they hang and another call comes and paper is piling up. And then these other people, they have to go through the pile of paper and find what is relevant for them. Because some of the calls are just asking for information, and some of the calls are from somebody saying that this is the third time in a row they are calling and that somebody's sick and waiting at home for 3 days. So we did a custom application for them that makes them, allows them to enter the information faster, and then for these three teams taking care of the response, they can filter the information they need. So it's nothing very complicated, but these two applications managed to speed the process and to make their life easier. In the case of the contact tracing, the time from collecting the data to having this data available in the Emergency Operations Center was 12 hours, and it became almost instantly. In the case of the call center, there was an article this summer saying that all the improvements that have been happening in the call center for months, including software improvements, brought the response time from an average of 5 days down to 24 hours, which is, I mean, if you think about it, if you are sick, waiting 5 days for somebody to help you is not very nice. But as I said, this is not rocket science. This is basically a lot of web forms, bunch of REST API calls, and a little bit of processing on the data. But it's something easy for us developers, right? However, we have a constraint that makes our life more difficult, and that's internet is not working, or slow, or you never know. So you have to make sure that applications can work offline. Fortunately, we have the help of an awesome piece of technology, CouchDB. CouchDB is a non-SQL database that stores JSON documents, and the part of CouchDB that makes it super good for offline application is that it's very good with distributed systems. And it has a couple of bonus. One is that it allows you to do MapReduce operations in your data with just JavaScript. So it's very good for data processing. And the second one is that it exposes a regular HTTP API. So if the only thing you have to do is basically store data and retrieve it and process it a bit, then CouchDB can be your backend. And that was the case for us, actually. So the only thing we are missing here is how to store the data offline in the browser. And for that, we were using another great open source library, PouchDB, that implements sort of CouchDB database, but in your browser. We also used a little bit of Angular and Cordova for the mobile application. I forgot to put the logo here. And this tech stack allows us to move very fast. For both applications, we have a prototype ready in 3 days. A prototype, I mean something that we can show to the people and ask them, like, is this useful for you? But even so, within a week, we had something in production, like something buggy and with not so many features, but it was helping already. And after a lot of weekends and nights of crazy bug fixing, Ebola was over in Nigeria after a couple of months, and we were asked if we can take our applications and use them in the other 3 countries, in Liberia, Sierra Leone, and Guinea. And that's when we started to find problems. The first problem we find is because, okay, so we created our first apps for Nigeria. And here you can see the difference on the scale of the outbreak. In Nigeria, you cannot even see the number of cases because in total there were like 20 sick people in Nigeria, while in Sierra Leone it was like 14,000. And we have started with our simple, basically following the PouchDB tutorial. We do this, we replicate our whole remote database in our browser. Awesome, we can work as if we were all the time online. Yeah, of course, that was not such a good idea. The browser started complaining that we were being too greedy. Apparently, browsers have a limit for the amount of space you can take. Since we were very stressed and we have so many things to fix, we thought like, well, Chrome's let us use 6% of the hard drive. We'll just do that, what can go wrong? Yeah, no, that didn't solve the problem. The next thing we saw is that the replication, the first time somebody was using the application was going like for taking 10 minutes to 20 to 40. And that was in Berlin, but they were saying like, yeah, 40 minutes, it's not that bad, right? But the people in Liberia were telling us like, no guys, this is never finishing. The latency in Liberia is worse, the internet is more unstable, so they were not even able to use the application. So the problem is that we just took the easy path and replicate everything, and that's take too much space, and replication is slow. But why were we replicating everything, really? Do we need everything? Well, use your domain knowledge and see what do you need offline. In the case of our contact tracing app, for example, we realized we only need contacts that are created in the past 3 weeks, because after that they are out of the quarantine. Only in my area, because a particular person doing contact tracing only working in one area, not in the whole country. If they don't have symptoms, because otherwise they are out of the quarantine too. And from those, only the names and IDs to show it in our dropdown. So we changed our replicating everything to replicate just the information we needed. This is our remote database on the left. And on the right, you can see that when we had connection to the database, we were getting a list of names and IDs. And we were storing that in our database in our browser. And then we could create follow-up information. And we will synchronize that to the remote database whenever we had internet. But we didn't need to have all these follow-ups in every single phone. In the case of the call center, however, it was different because we tried to reduce the data set, and still the smallest data set was too big. And also we realized instead of making things faster, we were making it slower. How is that? Well, if they were using paper, the operator will be taking all the information in paper, and the people sending ambulances, for example, will be here. I can just take the paper and hand it out to this other person. In our case, we were trying to have all the information available all the time in all the computer, which means that the operator will fill out the data, that will go all the way to the internet and back to the person sitting next to me. The problem is that maybe internet is not going to work for 2 hours, and then the fact of passing this information takes 2 hours, which is crazy. So what we realized is that we were really trying to solve a software problem almost for the sake of it, almost because we thought it would be cool to make it work like that. What we realized is we need these people to have the information within a call center available as soon as possible. And then maybe the other call centers can get this information with a little bit of a delay. So we forgot about PouchDB completely here, and we just set up a local CouchDB database in each of the centers. And then whenever they have internet, they can synchronize to the remote database, and then that information will get back to the other call centers. Actually, that allows us to have call centers that have no access to internet whatsoever, because you can sometimes hire a dedicated telephone line between them, and then the second call center will take care of synchronize to the internet. So solve real-world problems and replicate only what you need. A second very common problem if you are dealing with offline applications is dealing with conflicts. What do I mean by conflicts? This was our original data model in the database. And so we have the remote database and 2 contact tracers. Let's assume for simplicity that they only synchronize data at night. So we have day 2, both contact tracers have the information. Day 3, one of them goes to visit the person, and at night there is no internet. Day 4, the second contact tracer goes to follow up on that person, and at night internet works again, and they try to synchronize. And CouchDB says, okay guys, I have a document, you both have modified it, I have no idea which one of you is right. So I'm just going to set this as a conflict, and it's for you to decide. You can do that, you can decide what's the right information, but you can do even better by avoiding conflicts altogether. So what if you design your data model better and keep things that change together, and things that change separated? This way, each one of the contact tracers will only create new documents, and then there will never be conflicts. This will have another bonus, that is like there is less versions to maintain because you are not editing the documents all the time. So that makes a replication faster and takes less space. So for avoiding conflicts, choose your data model wisely. The third problem I want to tell you about is a nightmare of somebody making offline applications, which is data loss. We have this other application where we are registering people for a vaccination trial. It's basically taking their information, a picture, and printing a card. And we realized some people had cars, and they seem legit, and we don't have this information in our database. What we thought that happened was that at that moment we look and we realize, okay, IndexedDB is actually temporary storage. Who would have thought? How it works in Chrome is that this is your hard drive, and this is the space you have available on it. And Chrome can take 1/3 of it. And every single application within Chrome can only take up to 20% of this. But we thought, okay, this is still a lot of space, right? Especially in a computer. Although if you think in mobile phones, then it's not so much space. But still, we didn't have problems for a long time. However, one day we realized data has disappeared. And the thing is like, what we haven't thought is that if you keep using available space, then the space allowed for Chrome and the applications keep shrinking. And our application was actually making the user take pictures. And if they were not deleting these pictures, then of course the hard drive was shrinking very fast. So what happened when Chrome runs out of space is that it decides to remove the less recently used application, all the data from it. Yeah, so this is something to have into account. So those were some of the mistakes we made. We will make even more mistakes, I guess. But we realized many of them were like sort of beginner mistakes, and it was because it was all new for us. This is like state-of-the-art technology, and it's new for us, and it's new for the internet. So there is no post in Stack Overflow solving your questions. There is no 20 tutorials telling you how to scale offline applications. So it's a lot of fun and an adventure. What I can recommend you if you have to work with new technology is get an expert if you can. You only need one person that knows what's happening to help everybody else. We were super lucky to have one of the core developers of CouchDB helping us. He's somewhere around here. There. He didn't arrive on time to prevent us from doing the mistakes, but he helped us solve them. And if you cannot get an expert, you can still reach out to the community, because the thing is that if somebody is working in an open source project, they are probably very passionate about it. And if you have an interesting project and you are pushing the limits, then this is an interesting challenge. So reach out to them, be nice, help them create bugs, solve bugs if you can, add to the documentation, and you'll see that they help you. Okay, so actually, I wanted to talk about another thing, but I removed the slide because I thought I didn't have time, but now I have plenty. I went very fast. So another problem you can find if you are working with offline applications is that you don't have internet at all. So all the things I was talking about was about having internet sometimes and sometimes not. If you don't have internet at all, then there's still hope, right? And you just need to make sure that you manage to synchronize things between devices in some way. And how can you do that? Well, then you should check Matthew's talk from yesterday. I'll leave it there. Okay, so I showed you these charts with all the people that got sick and that died in West Africa, and that was pretty sad. So I want to show you, to end up on a brighter side, how is the state of the outbreak right now. We have Liberia that have 3 cases. Oh, it's not easy to see. It's 3 new cases on the week on the 29th of December. This is not so much. What is a little bit sad is that Liberia has been declared Ebola-free already twice, and this is the 3rd time they get a new case. But hopefully they have it under control. In Guinea, there is only 1 new case, and it was on 29th of October. So there is hope that they will declare it Ebola-free soon. And the Ebola outbreak ended in Sierra Leone and Nigeria. In Sierra Leone, that was particularly good news because the scale of the outbreak there was crazy. And they were so happy when it ended that they did this that I'm going to show you. Oh, no, back. Okay.
They want to see you rise, and when you do, they don't even lie. Come let them realize. Don't take many souls go away. Don't let them mercy. Don't even know what to say. Thank God that it's over. From the days, as watch me do. Ask them to, ask them to. Now watch me do. Ask them to, ask them to, ask them to. Now watch me do. Ask them to, ask them to, ask them to. Now watch me do. Ask them to, ask them to, ask them to. Follow me then. Ebola mash up the nation. It caused no frustration. Left some family pumping.
And I'm going to stop it because it's very long, but I think it's hilarious. Just check it out. And this is the people from the call center in Sierra Leone, by the way. So I think it's amazing that these people, after all the bad things they have gone through, they still find the energy to, I don't know, to celebrate that everything is over by dancing and having fun. So let me undo this. Okay. Okay, so it was an amazing experience to work in this project, to find that you can apply it to your skills to do something good for humanity. And I can totally recommend it to you. And, but it's also amazing for me that when we arrived here and we tried to help, we found that with all the technology with the way we are advancing technology and all the time we are spending on basically writing software, there was nothing prepared to deal with this kind of situation. And I mean, Ebola is quite bad, but it's still just an epidemic, and the way to deal with it is like any normal epidemic. So let's make it better next time. As the Time magazine said, this won't be the last epidemic, and when the next one comes, the world must learn the lesson of this one. Be better prepared, less fearful, less reactive, run toward the fire, and put it out together. Thank you very much.